In this lecture, we will discuss the problem based on homomorphism and some theorems related to the homomorphism, and also define isomorphism and endomorphism. So we start with the example related to the homomorphism. So we have a example. So we define homomorphism as let G and G dash be two groups. So then if function f is defined from G to G dash such that f of AB equal to FA into FB. So then we say that G is homomorphism into G dash. Same for onto function. That means we also prove that your f is onto. So then we can say that G is homomorphism onto G dash. So we take the example. So example related to the homomorphism. Let G equal to positive real number to multiplication. Operation is multiplication, and G dash is equal to set of real number under multiplication. Be any two groups. Be any two groups. We define these as G2. Function is defined as G2 G dash such that f of x, function of x, is equal to log x for every x belongs to G, is a homomorphism G onto G dash. So here we shall prove that f is homomorphism G onto G dash. It is clear. We have to prove that function is homomorphism and function is onto on G to G dash. So now we give the solution. So first we shall prove that function is homomorphism. So first we shall prove that function is homomorphism. So for proving homomorphism, we take two elements of G. So we take a let A and B belongs to G. और G के साथ क्या है operation into. So then function f of A into B is equal to function. How to define the function? Function we define fx equal to log x. So this can be written as x की जगह पे क्या आ जाएगा A into B. So this can be written as log A into B. So we have the log property, log m into n or log a into b can be written as log a plus log b. Log a plus log b. So by using the definition of function which is defined in the question, so fx is equal to log x. So log a you can write down as fa, or log b you can write down as fe. So f of a into b is equal to fa plus fb. The function के साथ में क्या ऑपरेशन है addition. That means for g dash. So we can say that function is homomorphism. F is homomorphism. So function is homomorphism. Now we move to the second part. Function is onto. So f is onto. So for proving onto, we take the element of g dash. So g dash element. So again, as we start take it. So let y belongs to g dash. So y be the element of g dash. So then there exists an element. An element. Which element? So that means function is defined as fx. Fx is equal to log x. Of fx, we say that equal to y. So y equal to log x. So when we take anti-log both sides, so this gives us e of log x. E raised to the power log is 1. So e raised to the power y equal to x. तो जो x एलिमेंट है वो किसका होगा g का. So y belongs to g dash. So then there exists an element that will be log y. So that will be e raised to the power y. log x. So that there is an element e raised to the power y which belongs to positive real numbers. So positive real numbers. So then such that, so we can say that such that, so f of e raised to the power y is equal to log into e raised to the power y, log of e equal to 1, so gives us y. So the image of e raised to the power y is y. So hence f is onto. So hence f is onto. So we can say that f is homomorphism. F is homomorphism G onto G dash. So for homomorphism G onto G dash, we shall prove first is F is homomorphism. That means F of AB equal to FA into FB, or as per a binary operation defined in undefined for the groups. Now, second we prove F is onto. Now we take another example for that understanding. So let G is equal to 0 plus minus 1 plus minus 2 plus minus 3 and so on be the group of integers under addition, then prove that G is G is homomorphic homomorphic to G dash. Or G dash is equal to 0 plus minus m plus minus 2m plus minus 3m and so on, where m is not equal to 0. So we see that as per the statement of the example, the G be the group under addition and G dash is also group under multiplication. Sorry, under addition. So function we defined as f from G to G dash. अब इसमें आप कैसे पता कर सकते हैं कि जो फंक्शन होगा इसका फंक्शन, दिस इज क्लियर कि फंक्शन f इज डिफाइंड फ्रॉम G to G dash, but what is the function for this? The function we can write down as fx is equal to mx. जो g दे रखा है आपका, जस्ट जो g डैश है उसमें क्या मल्टीप्लाई हो रहा है, m से मल्टीप्लाई हो रहा है, तो x को हम रिप्लेस करेंगे प्लस माइनस 1 से, तो दैट कैन बी कन्वर्टेड टू द प्लस माइनस m. दैट मीन्स वी मल्टीप्लाई प्लस माइनस 1 बाई m plus minus 2 plus minus 2m. So function fx is equal to mx. So here x belongs to g. So x belongs to g. So इस क्वेश्चन के लिए ये फंक्शन हमें खुद डिफाइन करना था एज पर द ग्रुप्स. So both groups are defined as G and G dash. So we shall discuss about the function. Now we prove that function is homomorphism. So f is homomorphism. So proving f is homomorphism, so same thing we will do here also. So we take the two elements, let x and y be two element of group G. So then f of x plus y, because both groups are defined for addition, so f of x plus y is equal to m of function क्या है हमारा m of x, तो x किससे रिप्लेस हो जाएगा x plus y से, तो m of x plus y. So this can be written as mx plus my. So mx plus my, so what is the value of mx? The value of mx is fx. So similarly we can write down what is the value of my, that will be the fy. So f of x plus y equal to f of x plus f of y. So by definition, so we can say that function is homomorphism. So f is homomorphism. Now we will prove that f is onto. So for second part, we shall prove that function is onto. So f is onto. So for proving onto, so we take the element of set G dash. So let Y be the element, Y be the element of G dash. So then there exists an element, an element X. So X equal to Y upon M. So we have the function fx equal to mx, or fx we write down as y equal to mx. So then x is equal to y upon m. So जो y upon m होगा वो किसका एलिमेंट होगा, g का. So y upon m in g. So we can write down then f of x, x means y upon m, y upon m equal to mx, और x क्या है हमारा y upon m. So m to m cancelled, so this gives us y, और जो y होगा वो तो obviously g का डैश का मेंबर है. So that means function is onto. So here we can say that m is not equal to 0. So function f is onto. So when function is onto, so f is homomorphism. F is homomorphism g onto g dash. Okay. Now we have a one theorem related to that. Let g and g dash be any two groups with identities e and e dash. So then first we shall prove f of e is equal to e dash. Second we shall prove f of a inverse is equal to f of a to the whole inverse. So we write down as function g to g dash is homomorphism. So now we prove that these two identities. So how to prove these two identities? So we say that let G be the group. So group means it satisfies the closure, associative, identity, and inverse. So G be the group. So we write down let. Do not write down let. Here we write down since G be the group. Since G be the group. So when G be the group, so E belongs to G, because E is the identity. And let A be the element of G. So by the property of identity, A into E equal to E into A equal to A. So now we operate the function. So f of AE equal to f of EA is equal to FA. So by definition of homomorphism, this can be written as FA into FE is equal to FE into FA is equal to FE. So we can write down this as FA into FE is equal to FA. So E dash be also the identity. So this FA can be written as into E dash, because A into E equal to E into A equal to A. So FA can be written as FA into E dash. So E dash be also identity. So E dash be also identity. So here we use the left cancellation law. So using left cancellation law. So by using left cancellation law, we write as F equal to E dash. Now we shall prove the second part. So for proving the second part, same thing, that is G. This is G dash. So we take A is the element of G. So FA be the element of G dash. So we write down here this FA. We can write down here E with the identity of G or E dash with the identity of G dash. So E dash be any another element which is belongs to G dash. So we write down by definition of inverse. So we have inverse definition is A into A inverse equal to A inverse into A is equal to E. So we operate the function. So we can write down F A into A inverse equal to F A inverse into A equal to Fe. So by using a definition of homomorphism, this can be written as Fa into Fa inverse is equal to Fe. We write down Fe. So what is Fe? By using first part, so Fe is equal to E dash. So we know that Fa into Fa inverse is equal to E dash, means A into A inverse. So you can write down as we say that A into B equal to B into A is equal to E. So B is the inverse of A. B is the inverse of A. So we can write down as F A to the whole inverse. So that means first we have proved this F A to the whole inverse is equal to F A into A inverse. So this is the second property by using the F function definition of homomorphism. Now we move to the next definition, that is isomorphism. For defining isomorphism, just we follow the one-to-one correspondence. That means a function which is 1, 1. So we define in this way. Let G and G dash be two groups and function f which is defined from G to G dash such that f of AB is equal to f of A into f of B. So this is for homomorphism and f is 1, 1. F is 1, 1. So this is for homomorphism, means G into G dash. So then F is isomorphism. F is isomorphism G into G dash. So again we can extend this again. F is onto. So then G dash is called isomorphic image, not homomorphic. So this is called isomorphic. In previous part is homomorphic, but here is isomorphic image. Isomorphic image of G. So the symbolically we represented F is G is isomorphic to G dash. That means F is isomorphic to G dash. So in isomorphism and homomorphism, there is a difference. In homomorphism, just we say that Fa into B equal to Fa into Fb. For isomorphism, we also prove that the function is 1, 1 also. So for proving function is 1, 1, so that means we take two elements of same set. That means x and y be two element of G. So we prove that fx equal to fy, then x equal to y. So this is the for now. We move to the next definition, that is endomorphism. La- Last definition, that is endomorphism. For defining endomorphism, so we write down as a homomorphism of a group into itself is called an endomorphism. Is called an endomorphism. A homomorphism of a group into itself. So that means G to G is called an endomorphism.